Okay, so let's start. What I want to do in this 6-7 minutes is talk about flow monitoring, why you would want it, what good can it do to your deployment. I'm going to talk about how do you get flow data and through examples, how you get it from the kernel. Talk about technology and how you can get it for very efficiently, low overhead, high kind of low latency. Go through an example environment, how that looks, how flow monitoring looks on that environment, and then talk a little bit about the challenges in order to productionize this type of monitoring. So first, I'm Jonathan. Let me introduce myself very briefly. I'm a retired captain from a technology unit in the military, where we built very robust systems. This is where I got introduced into large-scale in-the-field deployments and how do you monitor them, how do you react to failure. I then did a PhD where the research was how do you get very fine granularity monitoring, how do you analyze it with low latency, make decisions on how to fix the system, and then propagate that and make actions based on that data. I'm super enthusiastic about building these low latency, low overhead, high throughput, robust systems. Okay, so why would you want to do flow monitoring? So first, the flow of data between services in your system first gives you the architecture of your system. Many organizations don't have that. So for onboarding new developers, new SREs, new DevOps people, it's really useful. How do you audit it? How do you audit your high availability? If you have a system that should run on different availability zones, how do you make sure there's no dependency that you didn't know about that would hurt your high availability architecture? How do you know that your environments are isolated, that there's no dependency between production and staging environments, so on? Health monitoring, and this is the context with which Debasis used, kind of showed you Flowmill data. Can you find in your system which pairs of components are failing? And you can see, when you have microservices, you have multiple sources talking to multiple source APIs talking to multiple destination APIs. How do you figure out the pair that is failing? What availability zone it's failing on? What version of the service it's failing on? So how do you get very good data into where the failure is? This is both in game days and in production environments. And also communication between components of your system. So communication in the public cloud between availability zones or between regions is expensive, and also in private cloud, right? But how do you know which services are using this expensive resource so you can optimize? And I'm going to go through an example of how you can get this flow data. And the example uses Kubernetes, but the same kind of principles apply to ECS and to kind of vanilla, kind of if you're using EC2 directly, any orchestrator you might use. So in Kubernetes, you have pods and services. If you have a pod, it needs to communicate to a service. What happens is the service, let's say you have a pod A, wants to communicate to service X, and that service X is backed by a pod B that implements that service. Kubernetes has this component called kubeproxy that configures IP tables. And IP tables maps the addresses of the virtual IP address of the service X to the containers that implement it. So here to B. A opens a socket to X. I want to communicate to that service. And then IP tables translates X's address to B's address. And B sees packets as if A talked to it directly. So you have these two types of flows in the network that are exactly the same flow, but they look differently. They're hard to match. So how do you get the complete view of this flow of data between your components? You can use these three systems to extract metadata from and get the complete view. So one is the Kubernetes, the orchestrator API. Here you can get the address, so the name of the pod and its address. From the SS utility, you can get the socket information here in orange. So you can get A is talking to X, and also metrics on how the flow is performing. So here I've highlighted the number of bytes, but you can also get packet drops, round trip time, etc. And from the NAT subsystem, you can get this mapping. Here, A to X maps to A to B. Right? So there's all this data in the kernel. You can get it from the kernels to get a complete view. Once you have all this data from these three subsystems, you can assemble it to get a view of the flows in this system. There is a way to get this very efficiently. BPF has been around. It's a technology that's been around in the kernel for a few years. So the system call has been around from kernel 3.18. eBPF allows you to run snippets of your code on different events, on different functions that happen in the kernel. So this is great because now you can get, instead of polling, which is very expensive, you have to get records on everything that is in the system, all the sockets, not only the live sockets or what the things that changed. Now you can get only the changes, and you can get notifications from the kernel when these things happen, so you don't have these polling intervals where you don't have visibility in the middle. It's extremely safe. BPF has this in-kernel verifier that ensures that you cannot access invalid memory. And in the context of this talk, kind of getting this type of data, all the code runs read-only, so it cannot corrupt kernel data structures. It's also very fast. It's just-in-time compiled to very efficient machine code. This is the right mechanism to use to extract data from the kernel. So overall, you can get 100% coverage of all the communication between your applications without modifying your applications, directly from the operating system with extremely low overhead. So this is a big win. And this is what Flowmill uses. So let me go through kind of a staging environment and show you this is a map of a small staging environment that we run. Here you can see the Kubernetes nodes in the middle and the health checks that go to the different services, the different containers. On the left there, you can see the out-of-cluster traffic. The label is unknown. And our APIs and our front end. So you can see the traffic that's that's being served out of these APIs. Here on the right, you can see our flow analysis server. This is where we get the telemetry from eBPF, process it centrally as a service, and Prometheus scraping this telemetry, so you can query Prometheus for this data. And what you end up getting is these very fine-grained samples, fine-grained metrics of how your system is behaving. So in this case, we got 1 second per socket measurements. You have a lot of these measurements coming in, which means you can establish very good baselines of how your system is supposed to behave. So here in the red region is how you expect traffic to behave, and in blue is kind of the mean of how traffic is behaving right now. So you can have these automatic baselines and create alerts that adapt to traffic history and automatically alert you on changes. A little bit on what are the challenges it takes to productionize such a system. So first, need to take care that CPU overhead is low. eBPF is extremely efficient, but you can still shoot yourself in the foot with it. It's easy to instrument the wrong function that gets called millions of times per second. And it's easy to, in user space, when you process it, you really have to take care that you have low overhead per sample. So my advice to you, if you're undertaking this, is to profile and iterate. We've been able to get to extremely low overheads of 0.1% CPU. So you can get to extremely kind of almost negligible overheads. Just need the effort. The other thing is need to take care that network overhead doesn't become a huge cost. Because if you try for every socket measurement to encode the process, the socket IP addresses, as well as the data, it becomes extremely expensive. So the system that Debasis runs has extremely efficient encoding and compression on top. You have to handle security, so both for the data and for accessing it. And here, there's good standards. You should just, my advice to you, use TLS for telemetry, use OAuth for accessing front-end services, best practices. Other challenges is how do you get real time? So advice is make sure you build your streaming, your system such that it streams data in and processes it, not batch. Once you start batching, you get very low latency. So Hadoop-style Spark micro-batching is expensive. What we kind of, you would want to build your system such that it's very interactive. There are other things you need to manage. I think they're not kind of, you'd be able to do it. There's a cardinality you need to take care of. And kind of baselining your workloads and alerting based on these baselines is something that's kind of also a challenge, and I'm happy to talk to you if you're interested. So if you are interested, my email address is there. We have several, kind of my co-founder Mike Roberts here. So please hit us up. The website address is on there, and thanks everybody for listening.